Alright, so in this video, we're going to solve systems equations by elimination. First one, two equations, two variables. We can solve. X plus 8y equals 6. Negative x plus 3y equals negative 6. My goal here is to solve for x and y. We want to eliminate, this is the elimination method. We want to eliminate either the x's or we want to eliminate either the y's. In order to eliminate the x's or the y's, we want either one of them to have the same coefficient and opposite signs. Okay, what do I mean by that? Same coefficient and opposite signs. The coefficient in front of the x is 1, 1 and negative 1. The coefficients in front of the y are positive 8 and positive 3. Are either one of these coefficients the same? Do I have a 1 on both of them?
The x.
Do either one have opposite signs?
The x.
Okay, the x again, very good. So since I have these two already with same coefficient opposite signs, I can eliminate my x's. 1x minus x, or 1x plus negative 1x, goes away. 8y plus 3y, I get 11y equals 6 plus negative 6, I get 0. My next step here is I have 11y equals 0. What's my next step here?
Divide by 11.
Beautiful. Divide by 11 on both sides. I get y equals 0. Once I've solved for one of the variables, go back into either one of the equations and plug in for y. So I'm going to choose my first equation here. So I have x plus 8y equals 6. I'm going to plug in for y. So x plus 8 times 0 equals 6. Simplify. So I have x, 8 times 0 is 0, equals 6. So now this creates an ordered pair, 6, 0. So what does this mean? These are two lines, two linear lines. Okay? This is their point of intersection. So if we look at their graph, here, their point of intersection is at the point 6, 0. So here we have 2x minus 6y equals 4, negative 8x plus 6y equals 20. All right. The last problem we eliminated the x's. Right? It was convenient. It was the first number. Well, it doesn't matter which ones you eliminate, the x or the y. Again, what I want to look for is who has the same coefficients and opposite signs. Some of these problems are nice. They're already set up for us. So here, look at my coefficients here. They're 2 and negative 8. Are they the same with opposite signs? No. We have negative 6 and positive 6. Are they the same coefficient with opposite signs?
Yes.
Yeah, so in this case, I want to get rid of the y's instead. So I'm going to add this. 2x plus negative 8x, I get
Negative 6x.
beautiful, negative 6x. These go away, equal, and 20 plus 4, and I get 24. Negative 6x equals 24. My next step here will be then,
Divide 6 on both sides.
what kind of 6?
Negative 6.
Beautiful. Divide both sides by negative 6. X equals negative 4. Again, once you solve for one of the variables, choose any equation. Doesn't matter if you want to choose the first or second one. I'm going to go back to the first. So I have 2 times x minus 6 times y equals 4. I'm plugging in this negative 4 for this x value. So I have 2 times negative 4 minus 6y equals 4. Simplify. Negative 8 minus 6y equals 4. Solving a two-step equation, add 8 to both sides. Negative 6y equals 12. Divide both sides by negative 6. Y equals negative 2. So now our two solutions, or our one solution, ordered pair is negative 4, negative 2. So the point where these two lines intersect, so I'm just going to take this for a second, move this over. So the point where these two lines intersect, again, is going to be at the point negative 4, negative 2 on your graph. Okay, so the intersection point is -4, -2. This one solution, this one input value of -4, will give you both an output for both equations of -2. Let's take a look at another one. -7x minus 5y equals -10. 7x plus 5y equals 14. Now be careful on this one, okay? We have two special cases. Again, I'm going to look at both values. Do I have the same coefficient with opposite signs?
Yes.
Do I have the same coefficient with opposite signs?
Yes.
Okay, let's see what happens. -7x plus 7x. 0. -5y plus 5y.
0.
So 0 equals -10 plus 14.
4.
Does 0 equal 4?
No.
So this has no solution. Okay? So two lines that do not intersect. Two lines that do not intersect are two lines that are what? What's the relationship between these two lines?
Parallel.
They're two parallel lines. So two lines that do not intersect are parallel lines. Okay, so these two equations have the same slope. They have a different y-intercept, but they have the same slope. Let's look at another one. Another special case. -8x minus 7y equals 23. 8x plus 7y equals -23. Again, looking for my same coefficients. The -8x and the +8x have it. The -7y and +7y have it. So this is 0. The whole left side is 0. The whole right side, 23 plus -23, is also 0. 0 equals 0. So this is an infinite amount of solutions. Infinite. Or all real numbers. Now, what's the relationship between these two lines? There's two lines. If they touch everywhere, what can we say about these lines? What can we say about these lines? Yes?
They're the same line.
They're the same line. They're right. So they're the same line on top of one another. They touch everywhere, so they have to be right on top of one another. All right. They might just be different by a factor, but they're the exact same slope, same y-intercept. They're going right one on top of one another. It's hard to see two lines on top of one another, but they're both there. Questions so far? Okay. So these examples are a little different. They require a little bit more work. All right. If you notice, my x-coordinates, -2 and 8, they don't have the same coordinate. They don't have the same coefficient with opposite signs. My y's, again, don't have the same coefficient with opposite signs. So now I have to manipulate one of the equations. I want to get one of these to be the same. So it doesn't matter which one you choose. I'm going to choose the expert here. So I want this -2 to turn into a -8. How do I get -2 to turn into a -8?
Add -6.
You can add -6, or what other means can you do?
Multiply by 4.
Multiply by 4. Okay, so we're going to stick to multiplication on this one. Okay, so I'm going to multiply this entire equation by 4. And I'm going to distribute that 4 to all these numbers. So I'm going to say 4 times -2x, 4 times -12, and 4 times 24. I want to get -8. I want them to have opposite signs. So yes. So you want them to have both be an 8, but you want one to stay negative. This is already negative, so it's in our favor. So if I multiply my first one, so I'm going to have 4 times -2x is -8x. 4 times -12y is -48y. And then 4 times 24, anybody? 96 positive, right? So now this equation is now that equation. Okay, so the only difference is I multiplied that equation by 4, but it still represents the same line. It's just a factor of that equation, or a multiple of that equation, excuse me. All right, so now our first two terms, +8, -8, now that will simplify. 8x plus -8x goes away. +6y minus 48y, or plus -48y. Yep.
-42y.
X -42y equals, and then 96, or -12 plus 96, I get an answer of,
+84.
excellent, +84. Divide both sides by -42. Y equals,
2.
what kind of 2?
-2.
negative 2. Now, take this negative 2 and plug back into the equation. I'm going to choose the second equation here, 8x plus 6y, only because my 6 is smaller. So, but it doesn't matter, whatever one you want. So 8x plus 6y equals negative 12. Now I'm constantly writing this second equation here. If you guys want to take a little shortcut and not write, you could go and plug in right away, and that's up to you. So I have 8x plus 6 times negative 2 equals negative 12. 8x minus 12 equals negative 12. Add 12 to both sides. 8x equals 0. Divide by 8. X equals 0. So my point of intersection is 0, negative 2. Okay, so the two lines will intersect at that coordinate, 0, negative 2. 3x minus 6y equals 9. Negative 7x plus 8y equals 3. All right, so looking back at the last example, I multiplied one equation by a number to get the coefficients to cancel. All right, so this one, again, a little bit different. Can I multiply 3 by anything to get 7?
No.
Can I multiply 6 by anything to get 8?
No.
So in this case, I'm going to have to manipulate both equations. All right? So doesn't matter which one I want to simplify. I'm going to go, again, I'm going to try to eliminate my x's. What's the least common denominator or a common multiple of 3 and 7? 21. So I want to multiply this top equation by 7, and I'm going to multiply my bottom equation by 3. Okay, so my top equation in black is going to be 21x minus 42y equals 63. Keep this one in green, distributing my 3 throughout. Negative 21x plus 24y equals 9. All right, so in this example, I had to multiply both equations by by some kind of factor, so I could get both to simplify. 21x minus 21x. See you later. I got negative 42y plus 24y.
Negative 18.
Very good. Negative 18y equals, and I have 63 plus 9. 72. Negative 18y equals 72. Divide both sides by negative 18. Y equals, how many times does 18 go into 72?
4.
Close.
Negative.
Say it again.
Negative 6.
Negative 6.
Oh.
Is it negative 6?
No, it's negative 4.
It is 4. Sorry. You said 4 originally, right? Sorry about that.
Yeah.
Negative 4. All right, so negative 4. Take my negative 4. Take my y value. Plug back into my y value. I'm going to choose my first equation. 3x minus 6 times negative 4 equals 9. So I kind of got lazy on this one. I just went and plugged in directly. 3x plus 24 equals 9. Subtract 24 from both sides. 3x equals 24 minus 9 is 9 minus 24, negative 15. Good. And then my last step here, divide by 3, and x equals negative 5. And again, the x coordinate and the y coordinate, so negative 5, negative 4, is my point of intersection. And you should write it as a ordered pair.